In these videos, we're going to talk a little bit about files. So the idea of files, reading from files and writing out to files is really related to exception handling. So first we're going to just talk a little bit just about input and output to and from files, ignoring the exception handling part of it. And then in the next set of videos, we'll move on to specifically talking about exception handling. And as part of that, we'll talk about how to deal with exceptions related to files. But as a little bit of a precursor, we're just going to deal specifically with file input and file output. So we know that the data in our program is temporary, right? So our variables, our arrays, all of the things that we write into our programs, when our program ends, that data is lost. So the data that we use, the variables we use, they're only around as long as our program is running. And again, once our program is done, the data is lost. So if we wanted to retain some data beyond our program, so if we wanted to keep that data once our program was over, we have to use files. Or we could also use a database or something like that, but we're going to focus specifically on using files. So again, if you want data to persist beyond once your program is done, you have to store it somewhere, and one place to do that is in files. Now, Java uses what's called streams to represent the source of input data, so somewhere that you're reading data in from, or the destination of output data, so somewhere that you want to store your output data. There's two classes in particular, input stream and output stream, but these are pretty basic low-level classes in that they read and write only bytes. So a byte is an 8-bit piece of information, and these two classes are only capable of reading and writing bytes. However, most of the files that we work with don't contain bytes. They contain character data. They contain what we're used to, like text, right? So usually we need to use a more sophisticated stream type to be able to read the kind of files that we want to read and write to the kind of files that we want to write. Now, a quick note here, you might hear this term streams if you hear people talking about some of the changes that were made to Java in Java 8. Note that that use of streams is very different from the simple IO streams that we're covering here. So we're really just talking about kind of the traditional use of the word streams to refer to an input source or an output source. In Java 8, streams took on a whole new meaning, and it's not something we're going to talk about, but it is pretty exciting stuff for those of you who want to kind of dig a little deeper and look at the new capability added in Java 8 for streams. But just note that that's a very different topic than what we're talking about. So just in case you hear that term used elsewhere, again, that's very different from the simple input and output streams. So as I mentioned, our classes input stream and output stream are pretty low-level treatment of data, and we want to use more sophisticated data like text. So the way we do that is we nest together streams. So Java gives us a lot of stream classes. If you look at the Java API, you'll see there are many different classes to handle different kinds of inputs and outputs, and typically the way we work with them is we nest them together. So some streams are designed specifically to work with bytes in a file, like input and output stream that we just talked about, but other streams are designed specifically to work with characters, so traditional text like we're used to working with. And then still other kind of streams use buffering. Buffering kind of reduces the workload on your underlying operating system. So all of these things are things we want to be able to do. But Java doesn't just give us one class to do that. Instead, what it does is it makes each sort of stream type responsible or good at one kind of thing, and then we nest together all those streams to get the full capability we want. So, for example, when we're looking at writing to a file, there's essentially three classes that we're going to use. Now, there are different ways to write to a file, but this is a very common one. It's the kind of the standard approach, and this is the one that we'll be using. But don't think that this is the only way to write text data to a file. It's certainly not. But we're going to use three classes: print writer, buffered writer, and file writer. Oops, this should say print writer, not print stream. I'll fix that. So the outermost class that we're going to use is print writer. So we're going to declare an object of type print writer. Now, print writer class is really great because it has these methods print and print line, and those methods work just like how we're used to using them through the system.out.print and system.out.print line. So they'll print a line of text either with a return carriage or not with a return carriage, but instead of printing just to the console, we can print to other things like a file. So print writer is really good because it's sort of really user friendly from the user's perspective, us as the programmer, that is. But we need to do a little nesting in order to get the full capability that we want. So for example, we're going to create, in calling our PrintWriter constructor, we're going to send in an object of type BufferedWriter. So the BufferedWriter class is really good at buffering output data, again, to kind of relieve some of the underlying burden on the operating system. So we want that capability. We want to be able to buffer our output. So we nest these two together. We send an object of type BufferedWriter into the PrintWriter constructor. But we need to go even a little bit further in our nesting because we also want to be writing to a file. We don't want to just write to the console or anything like that. So to do that, we have to create an object of type FileWriter. So again, this is going to be another layer of nesting. And to the constructor of type FileWriter, we send in the name of the file. So again, here what we do, if we kind of wind back up, we create an object of type FileWriter by specifying the name of our output file. We pass that object to the BufferedWriter constructor, so that creates an object of type BufferedWriter. We pass that object to the constructor of PrintWriter, and that then gives us our PrintWriter object. So this is how we nest streams together, and again, it allows us to kind of get different functionality from different stream classes that Java provides, and gives us just then one final object that we can use to output our data. So once we've got that object, I called it out, we can invoke out.println, out.print, we can send in strings, and instead of printing to the console, it'll just print to file name.txt. Now, very, very importantly, you must close your PrintWriter output stream. Okay, this is critical. It always has to happen. If for some reason you're in the middle of writing to a file and something happens and your program is interrupted and the output stream was not closed, you will lose everything that's already been written up to that point. So the only way to save the information that's been written so far is by closing that output stream. So this is a really important piece of code that you have to include. You should always put it inside a finally block. We're going to talk about finally blocks when we get to exception handling, so don't worry about that quite yet. And you can also use it with a try with resources. Again, we'll talk about that with exception handling. So this is our basic setup for file output. Now, just like we might want to write out data from a file, we might also want to read data in from a file. So up until now, we've really been working with just getting data from the user through the keyboard. But of course, the user might have their data already in a file and just want to give us that file to use. So we're going to use a similar nesting. We're only going to nest 2 levels this time. Our outermost class is going to be scanner. So this is the class we're used to using to read from the console, from the keyboard rather. But instead of reading from the keyboard, we're going to use that same class to read from a file. So we'll nest it with the file reader class. So we'll create an object of type scanner, and to the scanner constructor, we'll pass an object of type file reader. Now to the constructor of file reader, we will pass an object of type file, which we create just from the basic name of the file. So again, kind of winding back up, this takes an object of type file, which we create by passing in the name of the file, passes it to the constructor of a file reader. That creates a file reader object. We then pass that file reader object over to the scanner class, which creates our scanner object that we can use to read from a file. So now that we've got our scanner object, what we typically will do is create a loop, and we'll say as long as that scanner object has something else to read, so this will basically say as long as there's more in the file that's waiting to be read, let's get the next line of the file. So we'll read a line from the file by saying filescan.nextLine. So this inputs one whole line of text or whatever from our file. We can do what we want with it, like, print it out. And then again, importantly, we should always close that input. Sometimes you'll see this omitted. Some people will forget to use it. It's not as important with input as it is with output. With output, again, if you don't close your output stream, you lose everything you've already written. With input, it's really good practice to get into the habit of closing that input stream, so make sure you do that. But again, sometimes you'll see people leave that line off. You shouldn't, though. All right, so let's do a little bit of practice. We're going to read in the contents of a file that has 1 word per line, and we're going to write those contents back out to a new file where all the words are on the same line, separated by a space. And again, right now, we're just totally ignoring exceptions. So we're going to deal with exceptions separately. Right now, we're just totally ignoring them. So I have my class here, input output practice, and I have an input file rather called input1perline.txt, and it just looks like this. Okay, so it just has where to go? It has hello, welcome to the world of files. Again, one word per line. Okay, so this is our input file, and it's saved as input one word per line dot text. Okay, so to read in, so first we'll read in from the file. So to read in, we're going to use the scanner class. And again, I'm going to pass that scanner an object of type file reader. And I'm going to pass that file reader an object of type file. And I'm going to pass that file constructor my one parameter that is the name of the file. So input one per line dot text. Now I'm getting lots of exceptions or compiler errors rather, because I have to import some things. So of course I have to import the util package to use scanner, but I also need to import the java.io input output package to use things like file reader and file. Now, I had said that for now you can ignore exceptions. You can't actually technically ignore them because you will get a compiler error here saying, hey, you got to deal with some exception type stuff. But again, for now, we're just sort of skipping that. We're going to deal with that next. So for now, I'm just going to add this little line here, throws IO exception to my main method header, and that's going to allow me to just essentially ignore the exception handling part of it for now. In general, this is bad practice, and we're going to learn better practice when we talk about exceptions. But for now, since we're really just focused on the input-output part, I'm going to use this little clause here so that we can just sort of ignore the exception part. Okay, so this creates a scanner object that's going to read from this file. And again, I do that by creating a file object, passing it to my file reader constructor, which creates a file reader object, which I then pass to my scanner constructor to create my scanner object. Okay, so now I'm just going to use a loop to say, okay, well, that file scanner has something else to read. So while there's more there, I'm going to get the next line. So I'll call it my file line equals file scan dot next line. So it'll read a single line from the file. And for now, just so you can see, we'll just print it out and then we'll deal with the input in a minute. Okay, so we can run this and there it goes. There's our text from the file, outputted one per line. Now, if we'd made a mistake in the file name, let's say we misspelled it, or let's say that file didn't really exist there, and we ran it, we would get this, our program would crash and we'd get this file not found exception. System cannot find the file specified. Okay, so you do have to make sure you're putting in the right file. If you're using Eclipse, this file goes again in the same folder as the source and bin folders, so one level up from my actual .java source code. Okay, but I don't want to actually print out the lines. What I want to do is I want to output them to a file all on the same line, right? That's what I had said. So I'm going to change this comment. The scanner object will read from the file. And then to write to the file, we're going to use a print writer object. So I'll create a print writer, I'll call it file out. And I'll create that as a new print writer. I'm going to send to that print writer constructor a buffered writer. I'm going to send to that buffered writer constructor a file writer, and I'll pass to that file writer. Now I could pass a file just like I did here, or the other option is I can just pass the name of the file. Output all one line dot text. Okay. Print writer, not printer writer. There we go. So again, I'm creating a new file writer object, which I pass to my buffered writer constructor. That creates a new buffered writer object, which I pass to my print writer constructor, and that allows me to create an object of type print writer. Okay. Now note that this file does not have to exist. In fact, right now it does not exist. This file is not here. The print writer class will create that file. That's part of what the file writer part of our nested stream output stream does. Okay, so now while I'm reading my file, my input from my file, I'm going to file out dot print, and I'll print that word that's on one line followed by a space. Okay, now if I run this class right now, it'll run no exceptions. it actually created that output file, but when I open up that output file, it's blank. And it's blank because I didn't close my output stream. So again, closing output stream is very, very important. If you don't close it, basically whatever you've written is lost. So this is critical. You must close your output stream or you lose your output. Okay, so now that I've closed that, I can run this again. And note that this time the file does exist. Basically, the print writer just overwrites it. So be a little careful about that. If you have a file that already exists and you write to it, you're just going to overwrite the content. So here now you see we get hello, welcome to the world of files, all on one line with our spaces in between. Okay. So that is your basics for reading and writing. Again, some of the key things here are this nesting of streams, output streams, and input streams. When you're reading from a file, you can use this loop with the has, next, and next line methods of the scanner class. And then when you're writing out to a file, you can use the print, or if you wanted to, print line methods of the print writer class.